All right, so when you want to find the upper and lower sum and you don't know how many rectangles it is, it's in rectangles, that makes it a little bit harder to draw, right? So this is where you have to start. You can think about what it might look like, but because this is what kind of function? It's a line, it's a linear function, right? And is it increasing or decreasing? Decreasing because the slope is negative, okay? So it's going to be, and this is the y-intercept. So just to draw a quick sketch of that, 1, 2, 3, 4, 5, 6 is here. And it's decreasing, the slope is down to over 1. Okay, so this is 0, 6, and this is, if we let y be 0, negative 6 divided by negative 2 is 3, right? So that's 3, 0. Okay, so, and we're only looking between 1 and 2, so from here to here, this is the area that we want to estimate, and we are going to have n rectangles. Okay, so the lower boundary is 1, the upper boundary is 2, so what's the width of those rectangles going to be? So it's 2 minus 1 over n, which is 1 over n. Okay, so that's the delta x, the width of the rectangles. All right, so let's start off with the right endpoints. It doesn't matter which one we start with, we can do right or left. So right endpoints, is that going to give me upper sum or lower sum? If I use, this is my left endpoint, a right endpoint would be over here, right? So it's going to give me an upper sum. No, because the right endpoint's going to be out here, right? So it's going to be above the, when you're decreasing, right, oh, no, I'm saying it wrong. That's a left endpoint that I'm drawing. Yes, you're right. Okay, so left, this is the left endpoint that I just drew there. So let's change that to left. Okay, sorry. So the left, the point that's on the function is the, if you draw in the rectangle, the point that's on the function, if it's on the left, that's a left endpoint. If the point that's on the function is on the right, then it's a right endpoint. Make sense? Okay, so left endpoint is going to be an upper sum. Okay, so let's use the formula then. So S of n, the formula that we found earlier, is f of a plus I minus a times delta x. Summation of that, I equals 1 to n, and then that's the f, that's the height of each one, and then times the width of each one is delta x. Okay. All right. So the sum of n rectangles is going to be summation I equals 1 to n of f of, so what is the left lower limit? 1 plus, and it's going to be I minus, again, that lower limit is 1. And then times delta x is 1 over n. Okay. And then times delta x is 1 over n. I minus 1? In the general formula, it's I minus 1? So for the first rectangle, if we're doing a left endpoint, I is 1, 1 minus 1 is 0, times the, gives me the left endpoint. Here? Right, but it's, oh yes, not A, it's 1, sorry. Yes, because it's going to be 1, the one that's behind it, so yes. The A is here, not there. Okay, so using the formula that we had earlier in the notes. Okay, all right. So then that's going to be summation. So this 1 over n out here that I'm multiplying, I can pull that out in front, right? Because remember, the only thing I'm plugging in for is i's. Everything else is considered a constant. So I can pull that 1 over n out in front. So then this f of, let's go ahead and simplify what's inside of there. So f of 1 plus I over n minus 1 over n. Okay, and then you're going to take that and plug it into the function. So it's going to be 1 over n times the summation I equals 1 to n. So this, we're replacing x in the function with all of that. So it's going to be 6 minus 2 times all of that. So 1 plus I over n minus 1 over n. And that whole thing is what we're going to sum up. Okay, so we have 1 over n times the summation I equals 1 to n of 6, and then we're going to multiply this negative 2 through, so negative 2 times 1 is negative 2, negative 2 times I over n is negative 2 over n times I, and then minus 2 over, plus 2 over n. Negative 2 times negative 1 over n, 2 over n. Okay, so then I have the 1 over n in front. Okay, and then I'm going to, 6 minus 4, or 6 minus 2 is 4, right? So I'm going to have summation I equals 1 to n of 4 minus summation of 2n times I. So what can I do with the 2n? Pull it in front, because only the i's get plugged in for, so that's a constant there. 2 over n. Okay, and then plus summation I equals 1 to n of, this is a constant, but we'll leave it in there. Okay? All right. So we have the 1 over n in front. Summation of a constant is what? What happened here? That should be a 1, an I. Okay, so that's 4n minus 2 over n times the summation of I. Do you remember what that was? Yep, so it's n times n plus 1 all over 2. Okay, and that's from the formulas that we talked about in the beginning. Summation of I is n times n plus 1 over 2. Okay, and then plus the summation of a constant, right? That whole thing is constant because it doesn't have an I in it. So it's the constant times the upper limit there, n. Make sense? Okay, so we just need to do the algebra here. So 4n minus, so this is 2n times n plus 1 over 2. So those n's can divide out. Those 2's can divide out. So I just have minus n minus 1. So that negative will distribute through. So negative n minus 1. Okay. And then these n's divide out. So that's going to be plus 2. So 1 over n times 4n minus n is 3n. And negative 1 plus 2 is plus 1. Any questions on that? Okay, so that is the left endpoint, or using left endpoints. Okay, so real quickly, if I then multiply that 1 over n through, that's going to give me 3n over n plus 1 over n. So those will divide out, so I get 3 plus 1 over n. So let me ask you a question on this. If I were to take the limit of this, as I let n, the number of rectangles, go to infinity, what happens to the 1 over n? It goes away, so that area underneath is 3. Okay, so that's where we're going with that. So we're out of time, but that was using the left endpoints. I want to show you real quickly, if we use the right endpoints, we get this. So if I take the limit of that as n goes to infinity, this goes to 0, and again I get 3. Okay, so when you let the number of rectangles go to infinity, then you get the same thing using upper and lower limits. All right?